All right, so 95 should be coming in. Yes?
We don't like her.
Boy. Hey. All right. Everett made it here. Let's see.
Shut up.
All right. All right. So let's talk about this new piece of notes for today. Even got a name on it this time. Good job, Ethan. We're proud of you. You didn't have to. That could have passed it back. So, where is she?
I saw her earlier.
I saw her in the hallway.
No, I don't know.
Yeah, I saw her
don't have a
too.
phone.
She's definitely not ditching.
Well, I hope not.
No, never.
I would never ditch this class.
Yeah, no, there's
Not
not
a million years.
I have no idea.
I saw him earlier.
Jeez. Oh, do you think?
The only thing I ever did.
All right.
It's the only thing I ever did.
So, building on what we talked about yesterday, some of you did not do as good on the quiz as you should have. So, you want to make sure that you are turning things around because, you know, let's face it, you might like me as a teacher, but you might not want to sit through my class twice, right? I mean, sit through a different class I teach, but let's go to the front of this. Now, please, do me a favor. If there's something on these notes where you're like, no, time out, stop. Stop, please. Looks like we're going to bring this into real world situations because that makes math so much better when we incorporate the real world, right? Okay, so let's think about this. For every input, you have one output. Okay. Input, what was another word for input? X. What's another word for input in X? Starts with a D, ends with an N. And domain, yeah. Okay. Domain. Output is?
Why?
And the other word for output in Y is?
Range.
Range. Okay. So they just have these fancy words. So for every X value, you can have only one value. So that's a function. That means the vertical line test, if you drew it and a vertical line test goes through your picture and touches it twice, it's not a function, but you still have a picture that's there, which is called a relation. Okay? Good? I think we have a thicker amount of homework. All right, so let's figure out what all of these mean. So I have the function at x is equal to 3x minus 5. They want us to find the function at 2. So that means I'm going to take 2 and I'm going to plug it into where my x had been. There was an x there. Now I'm going to plug a 2 in. Do the multiplication. 3 times 2 is 6. 6 minus 5. So I get 1. So if function at 2 gave me 1, what does function at 0 do? What do I have to do with that? Where am I plugging 0 in? Into x as well. So 3 times 0 minus 5. 3 times 0, I think, is 0 minus 5. So you get negative 5. Is that okay? I like it. And then we have function at negative 1. Let's get more creative. What do you think I should do with that negative 1 with our original function? Plug it in for x, yeah. So there was an x there. Now I'm going to plug a negative 1 in. Do the math. Get this. Okay? So if I have an input, I get an output. Seem okay? But letter D, does everyone recognize that letter D looks a whole bunch different than A, B, and C?
Yes.
Anyone there going, dude, it's identical? No, I think it looks different. So on this one, what I'm going to do is I'm going to take this, that's what the function at x is equal to, and I'm going to make the 10 go right there. It's not being plugged in for x. I'm removing f at x, and I'm just putting 10 there in its place. So let's see. This is going to give me 10 is equal to 3x minus 5. That had been an f at x, but I replaced f at x with the 10, and I set them equal to each other. That's like second or third day of Algebra 1. How did I solve that?
Plus 5.
Add 5, cool. I'll take the add 5. That's 15 is equal to 3x, agree? Divide by 3. Awesome. Okay, so x is equal to 5. Okay, so that was a much different process than the other three. Does everyone feel comfortable with that so far? You like? Hang on, I gotta play my video game real quick. Dude, you guys load this game yet? I heard it's the most popular one on the phones.
I play this game every time.
This is the best. I hit every target. Did you see that one? 9 for 9.
I'm on Mars.
Okay. May we move forward?
Mm-hmm.
Anyone stuck with any part of this? Okay. Oh, great. Dude, it's a story problem. Best thing ever. Okay, not really, but hey, let's go through it. So Lexi had her car towed when it broke down. Okay. It cost her $3 per mile to get it towed, plus a flat fee of $50. The function for her cost was cost at m is equal to 3m plus 50. This function calculates the cost per mile her car is towed. Okay. What do you think? Could this be a real life event? I mean, could you have to call a tow truck company because your car breaks down?
Yeah.
I mean, I think most people would realize that just leaving the car on the side of the road isn't the option, right? And I understand if you drive from here to Fort Collins, you'll see like 9 cars on the side of the road and they just leave them parked there. I don't know why. But for the most part, we have to do that. P at 12. Oh, I don't think that should be a C at 12 because that should match here. So that was kind of a grammatical error on our part. So what do you think C at 12 is? Yeah.
So you put the 12 where the n is in the like problem up there, and then you do 3 times 12 plus 50.
So you're saying that there had been an M here, but now I'm going to plug in 12. Okay. And 3 times 12 I think is 36. What do you think?
That is true.
36. And if I add 36 to 50, I think I get 86.
That is also true.
Okay, so let's talk about this. Let's make sense of what the problem's saying. This person needs to get their car towed. Tow truck company comes out, and they have a certain thing. So just to come out to the scene to get your car, and let's say they come out, and it's like, oh, I don't want you anymore. They're charging you $50 no matter what. Okay? Well, I'm not going to pay for it. Well, then you might be finding yourself in small claims court. Well, I'll get a lawyer. Good, so will they. Okay? So, what does this C at 12 mean? Yeah.
How many miles?
Yeah. This person needed their car towed a total of 12 miles, so it's going to cost them $86 to get it towed that far. Is that a good price? I don't know. You're sitting out in the middle of, really hot Arizona. You might be willing to pay whatever you want to get your car out of the heat. But that's what C at 12 means. So the person needs to get their car towed. It's a 12-mile journey. Took them $86 to get there. Do we feel comfortable with that so far? Anyone's kind of lost? Hope not. And then determine the output of the function when the input is 100. Interpret both the output and the input in the context of the problem. Okay? Determine the output of the function. So the output is like the y value, right? When the input is the x value. So what am I going to do with this part of the problem? It's written a little differently, so what does it mean? Yeah, so is the 100 going to go where?
100 goes on the left side when you put equals man plus 50.
Okay, hang on. I like that you're thinking on this, but hang on. The output of all these is like the f at x. Okay? The input means I'm putting something inside of this. So this one up here was actually c at 12. Rather than the c at x. C at x was the original equation. What's this? That was the original equation. And so we plugged in 12 here. So the input means it's inside the parentheses. So inside our parentheses, inside the c at x equals 3x plus 50, I'm going to plug in my input. So c at 100. So it's not equal to 100. We're saying, hey, the function happening at 100 is this. Let me just pause for a minute. Input inside the parentheses. It's the x value you're putting in, and you're getting an output out. 3 times 100? 300 added to 50? Okay. What does this mean in the context of the problem?
It was $350.
For what?
To tow the car.
How far?
100 miles.
100 miles to the car. You can't fear these word problems. This is okay. Tow the car for 100 miles cost you $350? I don't know. I don't know if that's good or bad or indifferent. I don't know. I fortunately have not had to worry about having a car towed in some time, so I don't remember the last time. Maybe I'm lucky. Maybe I just jinxed myself. I'm going to be that moron who gets stuck in the middle of the damn road over here on the dam. You know the damn road on the dam? Because guess which road I got to take today to go to a meeting after school? I got to take the damn road. Y'all want to know which road I have to drive up to get to my house?
The damn road.
No. I don't take the damn road. I got to take E470, C470 to Santa Fe. Get off on Santa Fe. Turn right on Mineral. Turn left on Jackass Hill. And I live at the top of Jackass Hill.
That's really nice.
So my whole commute today had a damn road and a Jackass Hill, and I was part of it.
Was it planned or was it on accident?
So when we were looking at houses and then we drove up Jackass Hill, I looked at my wife and said, I found where we're living. She goes, what if we don't like the house? I said, dude, it's off Jackass Hill. I gotta have this house.
Yeah.
So it was actually a good house too. So well, we like it. Yeah. Mr. Sturp is a jackass. I heard that. Good.
No, I said your kid's first word.
Oliver. Bring it down.
Teasing you.
Oliver is offended.
Come on.
Protect me from
He said that his first kid, like his kid's first word was jackass, and then he's just like, you just called me a jackass?
I did
Oliver's
not.
like, no!
Alright.
Son, you missed a lot.
Alright, so again, we're still continuing with this problem, talking about Lexi. Poor old Lexi in this $3 per mile, flat fee of 50 miles per poor car. It says, interpret the y-intercept of the function in the context of the problem. Okay, let's define a few things. What in the heck is the y-intercept? What is?
It's the context.
What is the y-intercept though?
Where?
Like just any linear equation. What does the y-intercept mean? Give me your verbiage.
Up and
Where-
down.
Where it crosses the line that goes up and down, right? So if you drew an xy axis, it would be where we cross, somewhere along this line. That could be our y-intercept, right? What is the y-intercept of this problem? 50. So we got like 50 right there, and then here's our linear equation. So our linear equation is going to get more and more and more. Down here, this is our miles that we're having it towed, right? And this is our price. But our starting rate for our guy to say, hey, I drove out to you. Let's take your car. Okay, it's $50 right now. Every mile we drive, $3. Okay? So why does the graph not go this way?
You
Because
can't
they're
drive
starting.
negative miles.
Thank you. What if he's driving in reverse though?
Yeah.
Still not negative miles.
Well, you have negative
Still
miles on the car, but not.
You're driving backwards, making that beep beep sound, and it still doesn't matter. You're still driving a distance. Okay. So interpret the Y-intercept in context. You call that tow truck. He puts your car up onto that flatbed of that thing, and you say, "Wait! I just remembered. This is how you started." Okay. He's gonna drop back off, saying, "Give me $50." Actually, he'll say, It'll cost you $50 right now for me to take the car off the flatbed." Well, I'm not paying it. Well, I got your car. Okay. Is it stealing? No. You made an agreement. All right. So interpret. So they're going to charge $50. Well, if it's a Ferrari, they might charge you more. That guy might pull up on scene. "Oh, you got yourself a Bugatti, huh? That's $4,400. Just put it up on the truck." Okay.
Wait,
I'm just kidding. I don't know this.
That's $4,400. You
That
cannot
would-
get a Bugatti for $4,000.
No, to put it on to tow it in case it breaks.
It costs more for each car.
I don't know. If you're a tow truck driver and you drove up and you realize someone paid like $1 million or however much it costs, wouldn't you want to charge that guy more than the guy who's driving the car that has like barely 3 wheels on it and the window that doesn't roll down and 4 different fenders that are different colors?
And the duct tape on the back?
Yeah, baby. You know the car I'm driving.
Yes.
That's my car.
All right. So then it says, interpret the slope in the context of this problem. So the y-intercept for this problem was 0, 50. So it's a point. So it means they're charging you $50 no matter what. But what does the slope mean on this problem? The slope, remember, is rise over run. That's what they use. So that just means, hey, what are you doing in the vertical direction and what are you doing in the horizontal direction? Okay, so if I had my graph like this right here, so if I choose these points right here, and let's just pretend I can draw them real straight. I don't have sugar tremors because I ate way too much sugar last night. What does the slope mean in context of this problem? Do they charge you more the further you drive?
Yes.
Okay. So in the y direction, every 1 mile extra you drive, or that your car is towed, you're paying how much more? $3. So you pay $3 more each mile. Oops, and I can spell each mile of the tow. Does that make sense?
Yeah.
So if you're going 11 miles and you said, "Hey, how much more does it drive another mile?" $3. How much more is it to drive 2 more miles? $6. How much more for the 3 more miles? $9. Keeps going, right? Up, 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 right? Feel comfortable? You doing okay on this one? All right. This isn't horrible, I don't think. I think we kind of can get a little perception. Oh my gosh, we're still dealing with Lexi. I just wish Lexi would figure out this car.
Darn it.
Lexi's a little read.
All right, determine. So that's the same function, right? C at m equals 3m plus 50. Determine the number of miles her car was towed if she was charged $400. So we had been plugging in, like if we plug 10 in here and 10 in here, we'd get 30 plus 50, so we get 80. So how do we figure out what to do if Lexi said, "Hey, it was $400 to tow my car"? Okay, so hang on. Let's kind of make this into a goofy scenario. Lexi finally gets home. Car has been towed. Lexi goes to her roommate going, "Dude, it cost me $400 to get my car towed." Still with me on this? I don't know who dude is. It's roommate.
Roommate.
So then roommate's like, "Dude, how much did this tow company charge you per mile?" Well, I don't know. They asked for $50 originally just to put it up on the stupid truck. Right? And then I think the guy said, hey, it's $3 for every mile you drive. What do you think?
$50 to put something on like a.
Thanks for being on. This is our third slide on the same problem.
And then
Okay, thanks for catching up. Yes, it's a $50 pickup fee.
I was saying, I just realized now that doesn't seem logical.
Every tow company will have this.
Really?
Yeah, it's just and it's
actually like real out.
Dude, they make big money. Big money. My mom
Big
wanted
money.
to be one, and I was like,
no, because Oliver doesn't want to make big money.
Oh,
no, I do.
you're real
But
about
I have
that big
other
money.
money.
Oliver's going on a. Oh shoot! There was a game show that used to scream about big money, but I can't remember what it was. I was like 12 when I saw it. Is that what it was? Come on, big money? Could be. Hey, how do I solve this problem? 400 equals 3m plus 50.
You subtract 50 and then
Good.
divide by 3.
So subtract by 50, so I get 350 equals 3m, right? And then Oliver, you said divide by 3? Is that what you said?
Yes.
Okay. Ooh, dude. Anyone have a calculator?
No.
No.
Emily? Have a calculator?
I
Do
do
it.
it on my phone.
Sure, get it. You got it?
I don't know.
All right. 350 divided by 3.
I have a phone.
It might be a decimal.
It is.
Okay.
Aiden.
Please,
Hurry up.
voices.
350 divided by 3.
I'm sorry? 116.67.
Yeah.
Sounds good. So what does that mean in the context of this problem? Lexi got home going, dude, it cost me $400 to tow my car. They charged me $50 just to be there. Roommate says, my gosh, how far did you get your car towed? They said, well, they charged me $3 a mile plus the $50 initial fee for a total of $400. Did you give the guy a tip? No, he sucked. He ran over 4 people. I didn't want to give him a thing. So what does 116.67 mean in the context of this problem?
That's how many miles?
Oh, I'm sorry, you said something good.
That's how many miles?
That's how many miles. 116.67. Where were these people at? Over in there in Grand Junction or something? That's far to get a car towed. You mean to tell me there wasn't a place to get your car fixed for 116 miles? 0.67. That you might be right. You might be right. I don't know. Don't know. Huh. All right. Let's finish this off. Okay, it says a customer claims that they were overcharged for their service. They were charged $149 for being towed a total of 33 miles. Were they overcharged? Well, we know that C at X is equal to 3m plus 50. So if they went 33 miles, I could plug 33 in here and get that. And that's 99 plus 50, because 3 times 30, which is 149. And then they say, no. That's not how it works. And the contract says, well, that's fine. Well, 149 equals 3m plus 50. Okay, so you're saying this is what you're charged. This is our rate. All right, subtract 50. I get to 99 equals 3m. Divide by 3. So m equals 33. So, sir, you said you went 33 miles for a tow? Yeah, well, that's correct. No, that's not correct. Well, sir, you said 33 miles, so our rate is this at 149. That was charged to you. So did this person get cheated for money based on their service call?
Yes.
Well, some people are like, dude, that's a chip, but let's face it. If you aren't in the ability to tow a car, they kind of dictate what they're going to charge. Huh. So letter F in this case, the customer had not been overcharged based on what they did. We just proved it two different ways. We proved that they went 33 miles, which they had said, and we also proved that at 33 miles it costs $149. Which way do you do it? I don't know. Just have to justify one way or the other. Can I move on? All right. Okay, now this is a little different. We got, thank good, Lexi. Who was it? Lexi, Carly? Lexi? Jeez. Hopefully her car's working. Hey, so we have this chart. We have y equals negative 3x plus 4. And then we have an input-output table. Okay? So we just said the input was what?
We don't have
What? We don't have this?
No.
I don't see the number.
It didn't print out.
Oh, that. Oh, I'm
I
sorry.
have it, just off the chart.
Just not the chart.
That's what we're talking about.
I'm sorry. You might have to generate the chart. All right. So let's do this. Highlighter. I have this here. And I have this here. And I have this here. All right. So I have yellow and I have purple highlighted numbers. And I know there's not on your paper. I'm sorry. And it's 1, 2, 3, 4. So we're loving life. Okay.
Oh, yeah.
So, input is X. So, this yellow, I'm going to plug in. I'm going to plug in right there. I'm going to plug in my yellow highlighter right here. What am I going to plug in that yellow region? Negative 4. All right, so that's going to be 12 plus 4. Looks like 16. So 16 is my output right here. All right. How am I going? Output is a Y. Oh, okay. So my output is going to be. So what am I going to put in? Nope, not one. Highlighter here. What am I going to put in right here? 13 and also? Now, and negative 14. So I'm going to do two different problems, but I'm going to use the same exact process. So let's do the 13 first. So I get this. So that's going to solve us one thing. And then over here, I'm going to go negative 14 equals negative 3x plus 4. Is that okay? Seem good? All right, how do I solve this? Anybody? Subtract 4. Okay, so that's 9 equals negative 3x. Negative 3. X equals negative 3. Cool. Do the same thing with negative 14. Minus 4 minus 4. We good so far? Okay, negative 18 equals negative 3x. Divided by negative 3. Negative over negative is positive. 18 over 3 is? Is that okay? Sorry that didn't copy on your paper. I think you get the basic gist of it. So Elizabeth, my bathroom policy is this, just so you know, because you're new. If you ever have to use the restroom, just go take care of it. Never have to ask. And then you can be like most kids and they climb over desks because they don't like walking in front. Is that cool?
Crawl too.
Crawl? Okay.
Aiden.
Oh, the bud. All about it. The voices are too.
Yeah, they are.
All right. Question? Stretching.
Bending out.
Oh, yeah.
Oh, dude. Lexi and Bennett better get together. Bennett and his friends. Oh, his friends might be Lexi is one of them. Decide to go bowling. The cost for the group is $15 for shoe rentals plus $4 for the game. Per game.
Why do you pay $50 for shoes per game?
No, you don't. You pay. You go.
Oh my gosh.
You go.
4 games.
You go and you're like, dude, I want those fancy green, yellow, and beige, or green, red, and beige shoes.
Oh, special bowling balls. I'm gonna put that man on.
Yeah, baby. And you're gonna pay $15. Now, let's say you just want to walk around the bowling alley with the cool shoes on. and you haven't bowled any games of bowling, you still drop $15, right? Anyone got that?
Shot 15 on the bowling ball.
Bowling, all right. So how much will it cost to bowl 2 games? Well, if each game is 4, so that's 4 plus 4 plus the 15, right? Or 2 times 4 plus 15. So that's like 23. So $23 to bowl 2 games? I don't know. Might be a good price. I haven't got bowling in a while.
You should do that and then do poetry.
That poetry?
Can we go on a field trip
No.
bowling?
Hey! Look who made it!
Are you pulling a list from 15 minutes till class is over?
Yeah, I know.
God. Were you ditching?
He was.
Okay.
He was at the Sizzler having steak. All right.
I wish.
Write a function that relates the cost of the outing.
He was taking a test.
Cost of the outing. C at x.
Are you doing?
How much did it cost to bowl each game?
It's 15.
15.
Oh, $4.
4. So 4 times the game plus how much do you have to pay no matter what?
15.
$15. That got you the fancy shoes. There's your function. 4 times the number of games. So the more games you bowl, actually, the less your most expensive game to bowl on average would be the first game. Does that make sense? Because the first game cost you 19. If you played like above 2 games, it cost you 23. And that means it went from $19 for 1 game to 2 games for 23. So that's $11.50. And if you add more games, 3 games is 27. So that's $9 a game. So the more you bowl, the less per game it would cost you. Even though it still costs you $4 per game, you have that $15 over your head. So if you were going to go bowling, you probably don't want to just bowl the 1 game, right? Can I move on? All right. Ooh. So graph the equation. All right, let's see. What was our equation I just wrote? C at x, or C at b, is equal to 4 times bowling plus 15. So what's my y-intercept have to be up here? 15. I don't think I have enough for 15 here, so maybe I'll count by 3. So 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. Is that okay? Mm-hmm. And then, so this is the price, and these are the games. So 1 game, 2 game, 3 game, 4 game, 5 game, 6, 7, 8, 9, 10, 11, all the way up to 12 games of bowling. This grid will take care of. All right, what's my y-intercept got to be on this problem?
15.
15, so we're right here. Agree? How much does it cost me per game?
$4.
$4. So I'm going to go up 4. So from here to here is 3, so I'm going to go up a little bit more, and then right 1. So there's our equation. That's it. That's the equation.
Really?
Use the graph to estimate the numbers of games the group could bowl for $30. 30 is here. What do you think? 4 games? Love it. Huh. Okay, real life? Sure. Kind of goofy? Absolutely.
Ah, that rhymed. Bars.
Can I move on? Am I almost done? I have no idea.
That's the last slide.
That was the last slide? I'm done?
Mhm.
Dude, you kidding? Oh, best day ever.
Don't be dumb.
All right, no homework is not correct. We would like for you to do pages 97 and 98, please.
Oh shoot, I already did that.
You already did it?
Yeah, I did the wrong
All right, so tomorrow we'll check that off. Let's see, what do we have up here?
Video on YouTube.
Oliver, it'll be quick.
What did I do?
This is the YouTube video.
Mr. Sharp should be a daily vlog.